Hi everyone. So just to prove to you that machine learning research is interdisciplinary here in UW, I just want to introduce a new project, lab. Think of AMPLab and RISE and so on, but faculty across CS and electrical engineering are starting. We call this the Robin Lab, Robust Intelligence Lab. And the reason is, why Robin? Anyone has a guess? Robin used to be the state bird of Wisconsin, plus it's a cool name. Okay, so these are the three instructors behind this new lab. Dimitris from EE, myself. You might be wondering, what a database person is doing up here. I'm doing machine learning and databases, so why not? And Sivaram, he's our systems guy. He's the guy that makes everything run fast. If you don't believe me, this is how he looks when he has his Spark pattern. He's one of the main contributors in Spark, so he knows his stuff very well. So what Yin and you might have in mind about machine learning, it looks like this, right? You have lots of data, you have a training box, you do data preparation, you have a bunch of models, runs greatly on hardware, and then you have your inference box, and during inference time, you just run your models. Everything looks great, but in reality, everything is a little bit more difficult to deal with. Your data, you might have adversarial attacks. You might have noise. Somebody went and set up your data on fire, or your data centers on fire. This happens very often with Google, for example. Or you may have like failures of hardware and so on. These are everyday life, situations when you're running at large scale. Not only that, but when you're training, you might want to train on the cloud. You might be training on edge devices, like your actual. How many of you have an iWatch? Okay, good for you. You're not being monitored by Apple, but you should know that machine learning is actually running their training on the watch, on the actual device, right? And the same thing for inference. You might have a bunch of different models. You want to reason about the different biases that these models have. You might want to reason about correlations of these models. You might want to know when these models fail, right? So we're starting a new lab around these questions, and in fact, we are focusing on three parts. One is robust training. What do I mean by robust training? You have noisy data, you want to ensure high quality both for your feature values and your labels. You have non-homogeneous hardware. You want to account for that variability. You have unreliable hardware. What happens, for instance, if a server goes down? How can I, reallocate my resources to actually maintain my speed and so on? The second thrust is I want to reason about edge devices. I want to reason about limited connectivity. I want to reason about limited power. I want to reason about resources that are actually, that these devices are resource constrained, right? So we need to be able to come up with new optimization algorithms with new machine learning frameworks that account for this hardware variability. And the final thing is inference. You all love group learning. It's great. It's really good at learning representations, but it sucks when it comes to actually reason, do high-level reasoning. You can have really accurate low-level reasoning, but when you try to make decisions, these models are not calibrated. They don't give you accurate, they don't give you predictions that you can use. Also, the uncertainty of different models might be correlated, so you want to reason about all these things. I don't want to take up more time, but if you want to find out more, we will be around during lunch, and please look us up, and also we'll be happy to chat also during dinner or during the breaks. Thank you.